Evaluating student perceptions of subjects and courses can reveal useful information about how to improve learning outcomes. Sentiment analysis and topic modeling offer effective methods for evaluating textual data. Sentiment analysis is important in education settings because student perceptions towards a course and their personal ability to succeed in that course can affect the extent to which they achieve learning outcomes. Mathematics can be a particularly challenging subject for many students. In fact, students who experience math anxiety find that it tends to affect their ability to succeed within that math course. Metacognition studies have showed that student beliefs about mathematics can undermine their problem solving performance. So it can be useful to conduct sentiment analysis regarding student perceptions towards these mathematics courses in order to increase effectiveness of courses. This study will utilize sentiment analysis and topic modeling of students' discussion posts in order to evaluate student perceptions of open enrollment, massive open online course titled How to Learn Math by answering the following two research questions. First one being, do students' discussion posts suggest a positive or negative sentiment towards their learning? The second one, which topics or words were discussed the most? With the first, our methodology will be sentiment analysis, and then with the second, we will apply topic modeling to identify these topics or words. In evaluating prior research related to student perceptions of mathematics courses, it provided valuable insights in designing this study. As mentioned before, metacognition studies have shown that student beliefs about mathematics can undermine their problem-solving performance. And building on that, McLeod in 1994 argued that researchers need to consider beliefs and emotions in order to research this effect. And such research must be done with qualitative rather than quantitative data so that we can identify beliefs of resistance or belongingness, which are then correlated to motivation. Using sentiment analysis in this study, it allows us to analyze the sentiment within the complexity of the learning experience by considering attitudes and beliefs and emotions. Expanding on this concept, we look at sentiment analysis to determine math students' view of their learning experience and determine if there's a need for reform in mathematics instruction within a course. Additionally, methods used in mathematics instruction itself seem to play a critical role in shaping the attitudes towards math. In looking at math anxiety, we can reduce anxiety through instructional prescriptions and hope that there should be an improvement in learning outcomes. Sentiment analysis can be used to identify specific areas that students have anxiety about in order to create methods to improve instruction and reduce student anxiety. In addition to articles improving student performance in mathematics courses, we drew upon articles specifically related to massive open online courses and discussion forums. For example, in 2014, a study investigated what sentiment analysis can truly reveal regarding students' opinions about a course. They analyzed a MOOC discussion forum in order to evaluate the attitude as communicated through those posts. They explored how student emotions were related to the curriculum and key course tools and found that student emotions were correlated with the number of students dropping out of the course each day. These results show the value of analyzing discussion posts to determine student emotions. Thus, we felt confident when proceeding to use sentiment analysis as our method and topic modeling for our study. In diving into the methodology, in order to create our research question, sentiment analysis was used to analyze a large data set of student responses gathered for the course called How to Learn Math, provided with the data from Stanford University. This method was ultimately chosen for its suitability as a tool, automatically sorting and grading the responses using natural language processing. The sentiment analysis method is highly effective at providing valuable insights into large sets of textual data, and in the context of education and course management, can provide course authors and instructors with critical information that can be used to improve and modify the course for future learners. The study reviews data provided as part of an open enrollment, massive open online course provided by Stanford University. Interested students were able to enroll free of charge from anywhere in the world and with any level of prior knowledge of the topic. This created a large and diverse data set of textual responses. From using sentiment analysis, these responses were identified as having a trend of very positive, positive, neutral, negative, very negative, or none. Participants in this study include a group of 40,000 students who produced a subset of 10,000 entries related to the course. Of the students participating in the course, there is a strong trend towards female participants, as well as participants who, at the time of their enrollment in the class, had completed a minimum of a bachelor's degree. The final data set used as part of the present study represents approximately half of those entries. The participant data has been anonymized in the final dataset using tokenized qualifiers, which represent the data being redacted without breaching the anonymity of the participants themselves. The data itself is provided by Stanford for academic use and includes the relevant references to demographic data, textual data, and other points necessary. The final dataset, after pre-coding by independent experts, represents those posts which include only complete data and exclude any malformed and/or missing scores. This existing data is used to answer the established research question of whether the students' discussion posts suggest a positive or negative lean towards their overall learning experience in the course following sentiment analysis using a sample of 4,999 discussion posts. Of these discussion posts, a sample of 100 was created using the sample operator within RapidMiner and the CSV file provided by Stanford University. This operator was then connected to the data documents operator, and the attribute of text was applied so it process would only run the column containing the discussion posts. Next, the process documents operator was employed, applying the term frequency inverse document statistics model. This model adjusts the weight of high frequency words in a document or file to determine how rare words are across a document. The filter examples operator was next connected to determine which examples of the set should be kept and which should be removed. This operator ensures the examples meet the conditions necessary to run the analysis. Finally, the sentiment analysis operator was added in order to determine the polarity of the discussion posts and whether or not the machine considers them to be ironic or not ironic. Within the process document operator, some subprocesses were added to further refine the results by using the following operators: tokenize, filter stop words for English, stem, porter, and transform cases. The tokenize operator breaks text into phrases, words, or other elements that are meaningful. The filter stop words removes other words that are not likely to be useful, such as prepositions, articles, and so forth. The filter stem porter operator then converts instances of similar words, such as learning or learned, into one occurrence of this type of word. This prohibits inflections of the same word from counting as separate occurrences. The final operator, transform cases, is used in order to transform all characters to lowercase. This keeps the program from misidentifying words as different words based on whether capitalized letters are present. Finally, the output of sentiment analysis was connected to the resolution, and the machine ran the process to produce the results of the sentiment analysis. After running the sample, results indicated a positive sentiment overall with the following polarity results. Based on these findings, we concluded that the majority of students' posts demonstrated positive sentiment or favorable learning experience in the math course, or at least in terms of the way they were discussed on the message board. After validating semantics, those statements that were giving negative polarity, 3 of those 12 comments displayed positive emotions towards the class, indicating an even more positive sentiment. Now, moving to topic modeling, we were able to use the same dataset. Overall, topic modeling discovers themes of a document or file and analyzes the structure for repeated words or topics to categorize into those themes. And they're determined by a probabilistic topic model. Starting off, the LDA allocation method allows the data to be analyzed for topics. Then from there, the number of topics was set to 5, and the top words per topics were also set to 5. Through the topic model process, despite the 2-topic model having the greatest log likelihood, it was found that the 5-topic model would be the best when considering the value of perplexity, as it is a measurement of how confident the model is about the distribution of words of the topic. This model had the lowest value for perplexity and therefore is the most confident about the distribution of words per topic. After performing the 5-topic model, the following topics were indicated. Topic 0 indicates the student was able to learn from making mistakes. Topic 1 indicates the question was shared via video session within the course. Topic 2 indicates the student was able to think through the number problem by seeing it worked out. Topic 3 indicates the student groups perform math together within the school with the help of a teacher. Topic 4 indicates the math students were able to think freely within the course. In reviewing the results of our analysis and comparing with similar studies and scholarly data related to the use of sentiment analysis in higher education, it's clear that these results constitute an appropriate use of this method and concur with other studies. Sentiment analysis provides useful avenue in teaching and learning for ascertaining course impressions and content delivery or learner success. The ability of sentiment analysis to automatically score, code, and grade large sets of textual data is of paramount importance to instructors and designers during the assessment phase of a course following its delivery. This data would, in other applications, be challenging and prohibitively large to analyze, resulting in the loss of valuable information that could otherwise be used to improve the course or assess an instructor's perceived performance from the perspective of their students, as well as similar applications. In short, due to the nature of natural language processing employed in this method, large swaths of textual data with critical impressions, contextual data, and valuable feedback would otherwise be unavailable to educators and thereby impossible to use in the conduct of their course design and professional